So today we are given the statement S of n is equal to log 2 plus log 3 on 2 all the way to log n on n minus 1. And we are asked to prove through the principle of mathematical induction that for any integer n greater than or equal to 2, our statement S of n is equal to log n. So first, let's get into the basis step. Since our lowest possible integer is n equals to 2, we will substitute this number into both sides for our basis step. In the left-hand side, putting n is equal to 2 into log n over n minus 1, we get log of 2. It isn't necessary to do the substitution, as you've probably realized that our basis step always involves the first term. That is, in our left-hand side, we have log of 2. But it's nice to show where it came from. Now on for a nice clean substitution into our right-hand side. Putting 2 in, we get log of 2, which is equal to our left-hand side. We have therefore completed the basis step. On to the inductive step. We assume our statement is true for a fixed positive integer k greater than or equal to 2. Note that it's not greater than or equal to 1 since our n cannot equal 1. If we assume this is true, it's going to give us log 2 plus log 3 on 2 plus log 4 on 3 all the way up to log k on k minus 1. And we're assuming this is going to be equal to log of k. Now, on to proving our statement is true for n is equal to k plus 1. First, before we start, what exactly do we want to show? Well, we want to show that when n is equal to k plus 1, that log of 2 plus log of 3 on 2 plus log of 4 on 3 all the way to log on k plus 1 over k is equal to log of k plus 1. Getting into this, our left-hand side, as aforementioned, is equal to log 2 plus log 3 on 2 all the way up to log of k plus 1 on k. Then, using our assumption from before, we can replace the first k terms with log of k, so our left-hand side is much shorter. That is, it's log k plus log of k plus 1 on k. Then, using our familiar log rule, that the sum of two logs is the log of the product, we get log of k times k plus 1 all on k, where we can now cancel the k's. Our left-hand side is now equal to log of k plus 1, which is equal to our right-hand side. And so we've shown it's true for n is equal to k plus 1. This justifies our inductive step, and we have now proved that the statement S of n is true for n is greater than or equal to 2.